folks, I just wanted to run through some of the details for Lab 6. Just a reminder that this one, there's a shorter turnaround. It's due the final Friday at 5, I believe, and no late submissions for this one. So the idea for this one is we want to look at implementing some features in languages that don't naturally support them. So the two things we're going to play with are higher order functions and variadic functions, functions that take any number of arguments. And we're going to be implementing the higher order functions we'll do in C++, but the variadic functions we'll do in both C and C++, just to see some of the hoops that we have to jump through to achieve this. So you're going to be editing, you're going to be submitting sort of 3 separate parts in the repository. So you're going to be doing one part where you're implementing a variadic function in C, in file var.c.c, one where you're implementing a variadic function in C++, and you're going to be modifying the var cpp.h, so these are going to be compiling 3 separate programs, and one where you're implementing a higher order function in C++, modifying higher.h. So 3 separate files for these. The other thing for part 2 there is, back up. In part 1, I've provided a main routine that will test your function. In part 2, I'm going to get you to implement your own main routine to test the function. And again, you can take a look at the idea in part 1 if you want some ideas on how to come up with a testing for it. And then in Lab 3, you're just going through implementing the higher order function. And I've provided, or in part 3, I've provided the main routine again. So that's the basic idea. Again, when you grab the repository, let me see if I can find the right beast here. When you grab the repository, you'll find the collection of files, makefile to build the 3 programs as usual. So the they'll compile the variadic C into a lab 6C executable, the variadic in C++ into a lab 6 CPP executable, and the higher order function in C++ into a lab 6 higher, I believe, executable. Just confirm that. Yeah, we've got our 3 executables that it'll build for you. So again, you've got a few files to modify. Just treat the 3 parts separately and things shouldn't be too bad. None of them are that complex. It's just a little unusual for some of these cases. So what you're going to be doing is implementing 2 versions of variadic functions and 1 higher order function. In the examples subdirectory in the repository, you'll find sample programs for each that show implementing variadic functions in C and implementing variadic functions in C++ and implementing higher order functions in C++, following the patterns that we're going to be using. So there should be sort of good syntax examples. And as far as kind of supporting content goes, if you duck over to the lecture resources page, there's a section on implementing higher order functions in general, but specifically in C++, given in that the March 21st to 25th, the end of that week. And there's a section on doing the variadic functions in C and C++ with slides and video and sample code in this week's notes. So there is hopefully relevant and useful material in there if you're running into issues with some of the approaches. So in the 2 variadic functions, you're implementing a max key function. So the idea is there's some struct that's got a key and a value. The key is an integer, the value is a double, and you're going to be passed and a whole bunch of these things as part of the function. So somebody might call the max key function and pass it a single one of these structs or a pointer to one of these structs. And you're going to go through and say, okay, well, the biggest one is that one because it's the only one you passed. But it's possible they'll pass 3 or 5 or 10 or 50. So you're going to get any possible number of parameters, and the idea is that your function walks through all of the parameters that were passed to it and finds the one with the biggest key. Keeping in mind that there are pointers. Once in a while, somebody might have passed a null pointer, or even they might have passed all null pointers. So if there's nothing but null pointers, just return null. Otherwise, you want to return a pointer to whichever one of those parameters had the biggest key in it. So that's the idea for both part 1 and part 2. You're implementing max key variadic functions. And I'll just quickly run through what that kind of looks like from a C and C++ perspective. So we'll take a look at the C version first. So the idea is to indicate, well, we're going to be using an stdarg library that's provided, and available through C, and it uses a bunch of different macros to provide the functionality we're going to make use of. So all of the things that we're going to be taking care of here are handled behind the scenes by those sort of hash-defined macros that we started talking about the other day. So to actually declare our function, you just specify the name, obviously whatever return type it's going to take, and the way we're going to handle our C variadic function is we'll expect one parameter up front that tells us how many more are coming. So in the case of the max keys, if they pass 3 of these struct pointers, then numargs will be 3, and then there'll be the 3 parameters. So there's this one extra parameter up front that tells you how many actual data values, if you like, are coming. So that's the format we're expecting. And then the ... is the syntax that indicates that it's a variadic function. So the idea then is that in our main routine, or wherever we're calling it from, we can call, in this case, max with however many arguments we want. This particular implementation of max just goes through and finds the largest of the parameters that was given. So, if they're going to pass 4 values, they just throw an extra one up front that says 4. If they're going to pass 1 value, they throw an extra one up front that says 1. If they're going to pass 2, they throw, oops, that should probably be a 2. Okay, so if the example was actually correct, that would be a 2. Oh no, sorry, I've got a 0 in there. I was looking at this thinking that was a 10.0. Never mind. Okay, hey, I actually got it right. Yay. So they're passing 3 parameters, 5, 10, and 0, and so we're saying 3. Then in terms of the actual implementation, again, we're using the features that are provided in this stdarg library. So there is a VA list macro that's provided that essentially allows us to declare an argument list that's going to be populated with all of the different parameters that are actually passed. And then this VA start actually initializes it from the parameter list that actually gets sent when the function is called. So essentially you're saying this thing's going to be a list of arguments, who knows of what type. This goes through and actually initializes it, and we tell it how many arguments are coming. So again, we just pass that along and say, okay, initialize it with 3, or initialize it with 5 arguments or 10 arguments or whatever it might be. And these things are actually getting passed on the stack. So this is basically just walking its way through the stack, grabbing the first 5 or 7 or whatever it was, things that were pushed on the stack as parameters. Then in terms of actually accessing the elements, we can kind of iterate through them using another macro called varg, where we basically say, okay, varg, we give it the arg list, and varg keeps track of which ones it's gone through so far, and basically just grabs the next one. So we say, okay, please grab me the next argument from this argument list, give it back to me, I'll store it in my variable. But we have to tell it what kind of data it's expecting. Is it a long, is it a double, is it some kind of pointer, right? In the case of this lab for max keys, it's going to be a pointer to the structs that we're actually passing as parameters. So we tell it what kind of data, and it grabs the next one, stores it wherever we tell it to store it, and then we can go ahead and use it. So in this particular example, we're just going through looking for the biggest of the parameters. So we're assuming that the first one is the biggest at the beginning, and then we'll just go through the rest of them. And at any time we see something bigger, we'll say, that's the new biggest one so far. So we're just repeatedly going through and grabbing the next thing out of this argument list as the specified data type. And when we get to the end, we can do a little bit of memory cleanup using this va_end macro. So it's basically just freeing the space that it used to initialize that argument list. So it's really not that bad a process. It's just getting used to using the macros and the fact that you've got to say, okay, well, give me the next one. Here's the data type it's going to be. For something like a printf or a scanf that can take a variable number of arguments, what those are doing is saying, okay, well, the first thing you pass me is going to be that format string. And in that format string, there's going to be a whole bunch of %ds and %fs and %s's and that kind of thing. So I can just go through the string, find out how many arguments are expected, so I can use that to specify how many arguments. And as I'm going through them, I just kind of go through that list. The first one is, a %d, let's say. So that means for the first one, I want it an int. And the next one might be a %s. So for that one, I'll say, I want it to be a char star. So that's how printf and scanf can go through and handle variadic calls where there can be different types of parameters as well as different numbers of parameters. But again, it's just a matter of working out the mechanics once these macros are available to us. So that's the idea that you're going to be applying for the first one. And then for the second one, the C++ version, you're going to be following a very different process. So in C++, with the templated system, we can go through and set up essentially a recursive set of functions that will handle all the different possible number of arguments. So what we're going to do is we'll set up, if you like, a base case function that's going to be used when just one argument is passed. And then we'll set up a recursive version that we'll use when more than one argument is passed. And you can have more than one base case. You can have one base case for a single argument, another base case for no arguments, another base case for 3 arguments. But in any event, you're going to have your base cases and then the general case that says, okay, if they pass any number greater than the base cases, here's what we do. So again, in this one, this particular example is just going through and getting the sum of all of the arguments. And so if they pass just a single one, it's just the value of that argument. So we're using these again as templated functions. In this case, that'll work with pretty much anything that we can actually pass and return. For the sum, if we go through and use the plus operator to add things together, then the templated system will work on any data type that is supported by some version of the plus operator. So we could conceivably use it with numeric values and with strings and with anything else we've overloaded plus for. So that's the basic idea. The syntax is the tricky part. So for sum, right, logically we can say, well, if they pass more than one argument, then they're going to pass the first one and then a bunch more. And so we're going to set up our logic in this case as saying, well, if I want to get the sum of all of them, I'm going to get the sum of the first one and the sum of all the rest. So we'll make a recursive call to get the sum of all the rest. It's just a matter of getting the syntax for this. So when we want to use a variadic specification for a parameter in C++, instead of just saying type name and then some name that we make up, it's the type name ... to indicate that this is the kind of all of the rest, and whatever name we want to use for all of the rest, so args list or args or something like that. So this is the name of the data type, right? T was the name of our kind of generic data type. Args is the name of our data type for the rest of them. So the way we specify the actual parameter list then is with the args ... to indicate that, again, this is variadic, and whatever name we want as the actual parameter name. then in the recursive call, we actually pass that, but again, with the ... added in. So once you get used to the sort of unusual aspect of creating your type names, your variable or your parameter names, and where to put the ... dots, it's actually a relatively straightforward process. So again, you'll tackle something similar with the max keys this time around, and hopefully that won't be too bad. And then for the final one, the higher order functions in C++, well, essentially we have to tackle, if we want to pass a function as a parameter in C or C++, we have to pass a pointer to the thing. So this is playing with function pointers. So the idea with a function pointer is that when you're specifying it as a parameter, you specify the return type for it, the parameter types that it's expecting, how many and what data types, and again in this case we're going to make it templated so we can pass different types, and then the *f, but in brackets so that the compiler knows that f, or that the asterisk belongs with our function name and not with the return type. So that is the kind of syntax that we're looking at for going through and specifying the function pointer we're expecting as a parameter. And then you can actually call it either using the *f to dereference it, or even just f and the arguments you want to pass. So in this case, this is saying, well, my apply binary function, so assuming we've got some sort of a function on two parameters that we're going to apply to some data. This one's expecting, pass a pointer to the function you want used, pass the first data value you want it to run on, and the second data value you want it to run on, call the function and return the result. And again, we could, in this case, I've got all of the data types as the same. We could use different data types, right? We could say template class XYZ and use X for the return type, Y for the first parameter, and Z for the second parameter. But in this case, we're keeping it simple and assuming these are all the same type. And that'll pretty much be the approach that you're looking at for your I have to go back and take a look at what the specs were for the higher order function in this one. But that's the idea. Then when you're actually calling it, you can pass anything, right? Any function pointer and data values that are appropriate for the data types and operations that you've got in place. So in this case, we've got a few different functions created. One function that takes 2 int parameters and returns an int, one that takes 2 floats and returns a float, one that takes 2 strings and returns a string, and they're just named sum, broad, and conc for concatenation there. So again, you can just say, okay, well, you can use the name of the function as a function pointer, just like we can for array names as a sort of array pointers, if you like. So we can pass it the name, and then whatever data values capture the result. So it's nice and straightforward to actually use, and the templating gets us pretty close to what we would think of as a higher order function. The only catch is that we just have the fixed number of parameters that we can expect. So f can't be a function on 1, 2, 3, or 4 parameters. It's got to be just a function on 2 parameters. Other than that, it shouldn't be too bad. So that was the intent. Again, there's in the lab notes and in the file itself, there's some specs on what I'm looking for from the update function that you're going to be writing as a higher order function, and hopefully things will go well. Let me know if you have questions.